Dear students, welcome back. This is Dr. Biju Devan. In this video, we will discuss chapter 9.13 Surface Integrals. How to evaluate integrals over a surface. That's what we are going to see here. Let f be a function for which the first partial derivatives fx, fy, dou f by dou x, dou f by dou y are continuous and are closed in a region R. And on a closed region R, then the area of the surface over R is given by, what are you going to do? You have a function f of xy, assume that this is f of xy, a function of xy. This is the region on the xy plane. Above this plane, what is the area of this surface? The surface is open all sides, isn't it? It's going infinitely larger. But we want the area of this surface over this region. This is what we are going to do, isn't it? And you might have seen this kind of integration in calculus 2. Here we go. Here the formula has been given us. Double integration, isn't it? dA. dA can be dx or dy, depending upon the region. You can choose type 1 region or type 2 region. Now what you got to do is 1 plus, this formula can be simply written square root of 1 plus fx square fy square and dx dy or dy dx, isn't it? And for limits of x and y should be chosen from the type 1 or type 2 regions. So this is first derivation of f with respect to x square, first derivation of f with respect to y, square it under square root, isn't it? This is what we are going to do. So here surface integral has been explained in as the sum of pieces, Riemann sum. Let G be a function of three variables defined over a region of three spaces, isn't it? The surface integral, surface S, containing the surface S, then the surface integral G of over S is given by this formula. So G of x, y is there are three variables here only. F has only two variables, isn't it? Mostly we are going to do problems of this type. Okay, there are four problems in a row. We will solve one by one on y sheet, isn't it? The first problem, note down, find the surface area of the portion of the plane. This is the plane. 2x plus 3y plus 4z is equal to 12, which is bounded by the coordinate planes in the first octant. Coordinate planes in the first octant. What do you mean by this? Roughly, I'll give the graph here. X-axis, y-axis, z-axis. When you are given a plane, how do you find the x, y, z intercepts? Divide this equation by 12. What do you get? X over 6, y over 4, isn't it? 3y divided by 12, which will be y over 4. 4z divided by 12 will be z over 3, which is equal to 1. This is the form x over a plus y over b plus z over c is equal to 1. Then the x intercept is a, y intercept is b, z axis intercept is c. Therefore this is the plane passing through all the 3 points a, 0, 0, this point 0, b, 0, and this point 0, 0, c. Okay, this is the and when you consider all the sides of this surface, and then this shape will be a tetrahedron. Okay, now you might have got an idea, isn't it? The area of this region over the xy plane, when you project on the xy plane, you can take z is 0. Obviously the projection will be falling on this ground. It will be like a triangle in the xy plane. So above this area, above this region, what is the area of the tetrahedron? That's what we are going to find. Okay, find the surface area of the portion of the plane given here, that is bounded by the coordinate planes. What do you mean by coordinate planes? xy, this is called this x, isn't it? xz plane, this plane is xz plane, this z plane is yz plane, this plane is xy plane. These are called coordinate planes in the first octant. So everything is starting from 0. First octant, when you separate a cube or a ball into 8 equal parts, this is the first part that starts, that has all the variables in positive sign, called the first octant. Okay, let's go ahead with problem number 1. Let's take our whiteboard. We will start with this problem number 1. See, what is the given plane, equation of plane? 2x plus 3y plus 4z is equal to 12. I want z because I want a function of xy. Z is a function of xy. 4z is equal to 12 minus 2x minus 3y, and z will be 12 divided by 4, 3 minus x over 2 minus 3y over 4. Now z, which is a function of xy, this is our function, and we know the formula for a surface integral, isn't it? The surface integral is, okay, we know the formula, double integral square root of 1 plus fx square fy square dA. This is the formula, isn't it? Area of the surface. Okay, now dA can be dx dy, obviously, when you project the surface on the xy plane, taking z axis as 0, right? So when you take z axis 0, so area, this is equation number 1, the area of 1 over the region, when you take z equal to 0 in this equation, this is A. What do you get? 2x plus 3y is equal to 12. We can write y is a function of x, isn't it? Divided by 12, we will find x over 6 plus y over 4 is equal to 1. Therefore, I can write this equation further. So you get this equation number 2 from A by taking z is 0. You are projecting on the ground, so taking height is 0, isn't it? So from this one we will get okay, what is y? From this one, what is y? Y, you can find this one, y by 4 is equal to 1 minus x over 6. So y is equal to 4 minus 4x over 6. Y is equal to 4 minus 2x over 3. This is all either this one or this one or this one. All the three are the equations of the plane over which you are going to find, or the region over which you are finding the area of this surface. Okay, now we got an idea what we're gonna do. From equation number 1, find fx, and this equation number 2 will be used to find the limits of x and y, and for this dA we will use dx dy and find the limits of x and y from this equation number 2 or 3, or take this 3. Now differentiate equation number 1 with respect to x. So fx, first term is 0 minus 1 over 2. That is it, negative 1 over 2. What is fy? First term is 0, second term is also 0, third term minus 3 by 4, then says minus 3 by 4. So 1 plus fx square fy square that are going to be used in this integral will be 1 plus fx half, negative half square, 1 by 4, and 9 by 16. So sum them up using, I think I need to sum them up. Take LCM of 16. So first term is 16 over 16, this is 4 over 16 plus 9. So you get next page 1 plus fx square fy square is what are the 29 over 16. So let's go with the formula area of S. See, when you project the tetrahedron is like this, x, y, z axis. The tetrahedron we got is 2x plus 3y plus 4z is equal to 12. When you divide this equation by 12, you get x over 6, y over 4, z over 3. Z over 3, which is equal to 1. So x intercept is 6, y intercept is 4 units, isn't it? 4 units, z intercept is 3 units. This one, and now when you project it on the xy plane, it will be a triangle on the xy plane. This is x, this is y. X 6 units, y 4 units, y 4 units. So the equation of the straight line which touches x at 6 and y at 4 is x over 6 plus y over 4 is equal to 1. And we have seen this one already. So this is the surface on which the area and direction is going on. So we can take a vertical strip to suggest how to get the limits. This is our vertical strip. Here this end will give limit for y-axis, and this end will give upper limit for y, and this end will give lower limit for y, and this distance will give the x values. Okay, so x is from 0 to 6. So y is from 0 to this line. This line has been found already. We have seen this equation of the line in the previous lines. Here y is 4 minus 2x over 3. So here y is equal to 4 minus 2x over 3. Here we go, double integral x from 0 to 6. I consider this one as type 1 region, isn't it? Type 1 region. We start with y first, dy and then dx. So outer integrations with respect to x. Inner integral 0 y is that is 4 minus 2x over 3. Now this term under square root of 29 over 16 and then dA. So 29 over 16 under square root becomes root 29 over 4 as a constant term. Now integrate with respect to y first. You get y from 0 to 4 minus 2x over 3. Our second integration is waiting here, dx. Now outer term is 29 over 4. This y upper limit will give you 4 minus 2x over 3, and integration should take place with respect to x. Now integrate it. This is square root of 29 over 4. Integrating this term will get you 4x minus 2x square over 2, which is 2x square over 2, which will be 6, which will make the denominator 6, and the limit will be 0 to 6. Now mere substitution of the upper and lower limit will get you the answer. Go ahead, which is, so area, we are finding area of S is equal to square root of 29 over 4. Substitute the upper limit here. 6 into 4. 24. Here 6 square into 2 divided by 6 square divided by 6. 1 6 can be cancelled. So another 6 is 6 into 12 is 12. So 24 minus 12. 24 minus 12, which is 12 again. So root 29 over 4 into 12, which is 3 times square root of 29. That's the end of problem number 1. Now we go to check what is problem number 2. The same equation has been given, but above the region, find the surface of the region, surface area of that portion of the plane. This is the same plane. We are getting same tetrahedron that is above the region in the first quadrant bounded by the graph. Okay, now the same tetrahedron is there, but you are not finding the area above this surface. You are finding there is another curve called this is a rose petal. R is equal to sin theta. A rose petal in the first quadrant, isn't it? So we find the area above this rose petal. That's all. Not all the entire triangle. Not over the entire triangle on the xy plane. There is a rose petal we are going to take on the xy plane. Above this rose petal we will find the area of this tetrahedron, isn't it? Surface. That's the difference with the first problem. Okay. Now I think it is better to convert things into polar form. Okay, if possible. We will try as much as possible with the ordinary values, and then if couldn't, we will move to okay, we will start. So the same problem should be recalled. Find the area. F, what is your f? F is the f of x comma y, the same z. Z is 3 minus 1 over 2x minus 3 over 4y, and therefore your fx is same on negative 1 over 2, and fy is negative 3 over 4, and square root of 1 plus fx square, fy square will be square root of 1 plus 1 by 4 plus 9 by 16. That will give the same square root of 29 over 16, which is square root of 29 over 4. The term, the integrand, isn't it? Now the formula for area of the surface is double integral square root of 1 plus fx square, fy square, dA. The add will become double integral. This term is square root of 29 over 4. dA can be dx dy, or let's write dx dy. Now we know on the xy plane, when you project the this on this, we have a rose petal which is known as r is equal to sin theta. This is the first quadrant, so from 0 to pi by 2, the theta value. So we can convert this integration into polar form, because we know dx dy can be written as r times dr d theta. Okay, and r varies from 0 to r. You can take a step here which will start from 0 and end at this curve. So r is varying from 0 to sin 2 theta, and theta is varying from 0 to 5 over 2. That's it. If you integrate it, you are done. So this will be double integral. This is 29 over 4 r dr d theta, and outer integral is theta, so outer limit is 0 to pi over 2. Inner limit is for r 0 to sin 2 theta. We have to integrate this one to get the area. That's it. And that is area of S is equal to area of S is equal to outer integral 0 to, so it is square root of 29 over 4, the constant outer, 0 to pi by 2. Integrate this term r, you get r square over 2. So r square over 2, and it is from 0 to sine 2 theta. Substitute, so take this r2 outside. What happens? Double integral, this is square root of 29 over 8, this 2 joins outside. So r square, this is 0 to, first integration is done, 0 to pi by 2, it will be r square sine square 2 theta, and now d theta. Sine square d theta, we have formula for it, root 29 over 8 integral 0 to 5 over 2. We can write by using double angle formula 1 minus cosine 2 theta. Actually, you write the formula here. Sine square theta is 1 minus cosine 2 theta over 2. But when there is this theta is replaced by 2 theta, sine square 2 theta, it will be 1 minus cosine 4 theta divided by 2. So this is cosine 4 theta. Means cosine 4 theta divided by 2. Isn't it? Now take this 2 with the 8, you will get square root of 29 over 16. Now integrate 1, you will get theta. Cosine will give you sine 4 theta over 4. Now the limit is from 0 to 5 over 2, which is root 29 over 16. The upper limit will give you 5 over 2 minus sine 4 times 5 by 2, 360, will be 0. And lower limit will make everything 0. Theta is 0, sine 0 is 0, so everything is 0. So only 5 over 2. That will make the answer square root of 29 times 5 over 32. That's the end. That's the end of problem number 2. Okay, let's go to check problem number 3. Problem number 3. Find the surface area of that portion of the cylinder. Don't be too much concerned about the graph. You can easily solve it even without the graphs. So we are going to find this portion of the cylinder that is above the region in the first quadrant bounded by. So they have simply given the limits of x and y. So obviously, when all the limits are constants, take dx dy or dy dx, it doesn't matter, isn't it? dA can be any one of this one because all the limits are constant. Okay, and now on this one we have to find z. What is z? Z is, z square is 16 minus x square, so z is square root of 16 minus x square. This is our integrand. This is our integrand, and from this we are going to find the f(x), f. So all these things are available. Limits of x are available. Let's go ahead. So the problem. So the function given is x square plus z square is equal to 16. So z square is 16 minus x square. Z is square root of or 16 minus x square to the power half, so that you can find this is your f of x comma y. Okay, so differentiate f with respect to with respect to x. It will be half 16 minus x square, half minus 1, and differentiate with respect to x, you get 2x. So this 2 and this 2 can be cancelled. It will be 16 minus x square to the power negative half into x. You can write f(x) is x over 16 minus x square to the power half. That is, f(x) is x over square root of 16 minus x square. Now from 1, what is fy? there is no y, so it is 0. Obviously the formula of area of S is equal to double integral square root of 1 plus fx whole square fy whole square dA. Now find the term square root of 1 plus fx whole square and fy whole square. 1 plus which is equal to 1 plus what is fx? Fx is given here. Square it will be x square over 16 minus x square plus 0, isn't it? So take LCM. 16 minus x square plus x square over 16 minus x square will give you the numerator. X square and negative x square will be cancelled. 16 square root of 16 will be 4 over square root of 16 minus x square. This is the integrand now. This is the integrand this time. So in the next step we will write a of s, which is equal to double integral. We will write the limits of x, y, 4 over square root of 16 minus x square dx and dy, the limit of x and y given, isn't it? Go back to the problem and check what is the limit of x and y. X is 0 to 2, y is 0 to 5, y is outer integral, isn't it? Okay. X is 0 to 2, y is 0 to 5. Before that we should use substitution method, trigonometric substitution method to integrate this inner integration, right? We will do that one. So let x is equal to 4 cosine theta. Refer back to the concept of trigonometric substitution that we have studied in first 2. X is equal to 4 cosine theta. So what happens when you take x is equal to 4 cosine theta? Dx will be 4 when you let's take x equal to sine theta. That's right, because when there is a square minus x square, it should be 1 minus sine square and 1 minus cosine square, isn't it? In this case we take it as sine theta, because sine, secant and tan, we have 3 options, so it should be 4 sine theta, not cosine theta. Okay, when you differentiate it with respect to theta, you'll get 4 cosine theta d theta. So the inner integration, this part becomes what? Integral 0 to 5, integral 0 to 2. Let the limits be same. We will be back to x again. 4 over, what is the denominator? We will calculate it here. 16 minus x is here. 16 sine theta. So under square root, that is square root of 16 is 4. You can take 4 outside. When you square it, this square sine square theta. Okay, are you clear about this one? Try it one more time. I'm actually finding the value of the denominator here, isn't it? So what is it? Square root of 16 minus x square is equal to what? 16 is 4 square, isn't it? 16 minus x is here. Again it is 16, it will be 16 sine square theta. So take 16 outside of the square root, it will be 4. Therefore it will be 1 minus sine square. 1 minus sine square is cosine square. So 4 times square root of cosine square. When we are discussing the positive side, you take positive cosine, you will get 4 cosine theta as your denominator term. So this term denominator will be 4 cosine theta, and dx is already here. Again it is 4 cosine theta d theta. This inner integral. It's inner integral. Now we find outer, there is a dy, outside of integration. So this 4 cosine theta will be cancelled with this 4 cosine theta. I will get only 4 inside. Integral 0 to 5 4 d theta, and this is 0 to 2 d theta dy. Integration will be 4 is constant, keep it outside. Integral 0 to 5. The inner integral will give you theta, and the limit will be 0 to 2. We never change the limit, it is the limit of x. So what is theta from the value of x? Find it here. X over 4 is equal to sin theta. Therefore theta is sin inverse x over 4, isn't it? So replace it. Outside integral is 0 to 5, theta will be, so there is a 4, theta will be sin inverse x over 4, and is from 0 to 2 dy. Now it's time to apply upper and lower limit, which is outer intervals 0 to 5. Go here, substitute upper limit x equal to 2 over 4 sin inverse 1 by 2 minus sin inverse 0. Sin inverse 1 by 2 minus sin inverse 0. Outside there is a term integral with respect to y, isn't it? And you know sin inverse 1 by 2, use calculator, you will get 5 over 6. Second term will be sin inverse 0 will be 0. There is a 4 outside. So 4 pi over 6 is constant, integral 0 to 5 pi dy, isn't it? So it will be 4 pi over 6 y from 0 to 5, which will be 5. So 4 into 5, 20 pi over 6, which is 10 pi over 3 will be the end of that problem. And we have one more problem to be solved, which is solved on the end of the page. What was that problem? Problem number 4. There has been a hint given. Find the surface area. Find the surface area of the portion of sphere x square plus y square plus z square is equal to 25, isn't it? That is above the region on the first quadrant. Again in the first quadrant bounded by, say, x0, y0, and this is ellipse. This is ellipse. The hint given is take integrate with respect to x first. You are supposed to consider the type 2 region, isn't it? Type 2 region. Okay. Integrate with respect to x first. So this is an ellipse on the xy plane. The ellipse, if it is on the ellipse, if it is an xy plane, when you divide it by 4, you will get x square okay, when you divide by 25, you will get 4x square over 25 plus y square over 25, which is equal to 1. That is x square over 5 by 2 whole square plus y square over 5 square is equal to 1. This is the form of the ellipse. So x-intercept is just 5 over 2, 2.5 here. But y-intercept is 5. So an ellipse whose primary axis is y. This way it goes, isn't it? Okay. So we are dealing with the first quadrant of the ellipse. So here you have to find a horizontal strip you choose, not a vertical strip. You choose horizontal because you are supposed to integrate with respect to x first. So you take a horizontal strip lower limit will be 0. Upper limit of x can be found from the curve. The curve is given here. What is x now? For these all for the limits of the double integration. Isn't the function can be taken from this equation, and first derivative can be found from here. Limits can be found from using this one. Both have lower limit 0. And we will do it a white page, right? Okay. Okay. The problem given is z square is equal to 25 minus x square minus y square, because it is a sphere. X square plus y square plus z square is equal to 25. From what we have found z square. So z is equal to square root of 25 minus x square minus y square, which is our function f. Function f of x, y is z, isn't it? So first derivative fx, this can be written as 25 minus x square minus y square to the power 1 by 2. So usually 1 over 2, 25 minus x square minus y square power negative half into minus 2x. It will give you fx. 2 can be cancelled, so it will be just negative x over 25 minus x square minus y square. Verify this one. This is power half or square root you can use. A similar way, if you try, they are symmetric, and so if the similar way if you try, fy will be minus y over square root of 25 minus x square minus y square f z will be minus z, no f z, only fx fy, that is okay. F is a function of z is a function of x and y, so this is f now. We got two terms, we can square them and add with 1 as well. Before that we will find, okay, let's find this integrand term. What is 1 plus fx square plus fy square? Let's find them first, and then which is equal to 1 plus fx, the first term, which is x square over 25 minus x square minus y square. The second term is y square over 25 minus x square minus y square. Take LCM, multiply this one here, isn't it? So 25 minus x square minus y square plus x square plus y square commonly divided by 25 minus x square minus y square, which is 25 divided by 25 minus x square minus y square. This is without square because we never taken square here. Okay, next page. The next page, what we get is square root of 1 plus, now take square root of x fy square is equal to 25. It is 25 case. The square root of 25 will be 5. This is 5 over square root of 25 minus x square minus y square. We have been asked to integrate with respect to x first. That's the hint given in this problem, right? Okay. Now we know that this is the region over which we are integrating is ellipse, where it's going this way. We are concerned about only this part, isn't it? Here x is 5 over 2, y is phi from the equation of the sphere. Equation of the ellipse. What was the equation of the ellipse? I will write you to refer the equation of the ellipse. 4x square plus y square is equal to 25. Okay, and now when we want to integrate with respect to x first, I write the formula here. Area of S, double integral over the region R. Let's write the limits later. Square root of 1 plus fx whole square fy whole square. This can be dx dy is given. So find x square from here. 4x square is equal to y square minus 25. X square is equal to y square. X square is equal to y is 20. Okay. It should have been actually. It should have been 25 minus y square. So it is 25 minus y square over 4. So x is square root of 25 minus y square over 4. Square root of 4 is 2. Now square root is only the numerator. So that is when you take a vertical strip, because when you want a vertical strip, when you are integrating with respect to x first, you take vertical strip. The lower limit is 0, upper limit is on the curve, which is given here, the value of x, isn't it? X value is given here, and y is from here to here, that distance from here to here, 0 to 5. So we now fill up this values in this integration and then proceed. That is equal to 0 to 5, the outer limit. Inner limit is 0 to square root of 25 minus y square over 2. Square root of 4 is 2, isn't it? Now this integrand terms here, 5 over 25 minus y square. I separated it and then written x square, because I am integrating with respect to x. Now the variable is x, so dx dy, variable is x. This term is considered constant a square. Go back to the under square root. These are under square root, isn't it? Now we are going to consider this term as a. Okay, then the variable is x. This will be a square. The previous method of substitution will be followed. Trigonometric substitution will be followed, right? Okay, let's go to the next page. Now let a is equal to a square is equal to what? This term is a square, 25 minus y square, 25 minus a square. Okay, this is equation number 1, or any other else. Let it be 1, chapter 1. Now this equation becomes what? Double 0 to 5. This is area of S. 0 to 5, 0 to no change in the limit. We are not changing it. 25 minus y square over 2. This term is 5 over square root of a square minus x square dx dy. So inner integration will be done by using substitution method. Let x is equal to the same concept. X is equal to a. X is equal to a sin theta. Therefore dx will be a cosine theta d theta. Now This term, the denominator will be under square root. A square minus x square will be a square minus x square is a square sin square theta will be a outside 1 minus sin square will be cosine. So this will be a cosine theta. Now this integration becomes integral 0 to 5 integral 0 to 25 minus y square over 2 5 over a cosine theta, and dx is a cosine theta d theta, and the outer integrations y. Okay, a cosine theta can be cancelled. What you get is 5 theta. 5 is constant. Keep the 5 outside, isn't it? And we have done the integration. We have already done the integration, so you must know it is 5. This one goes with this one cancelled. So 5 is outside. D integral of d theta will be theta, and the limit is 0 to 25 minus y square underscore over 2. Now what is theta? From here you can find what is theta. X over a is sin theta. So theta is sin inverse x over a. So we are going to replace here. The dy is outside. That is a of s is equal to 5 times integral 0 to 5. Okay, the lower limit is 0 and upper limit is square root of 25 minus y. Integration is done. So where is it? The answer we want is we have to replace the theta. So it is sin inverse x over a. Sin inverse x over a from 0 to square root of 25 minus y square over 2 dy. And you should remember the choice of a. What is choice of a? Go back. Yeah, a square is 25 minus y square. Therefore, what is a? A is square root of 25 minus y square. This is what we are going to use there, right? A is square root of 25 minus y square. So here we go. 5 integral 0 to 5 sin inverse x over a is square root of 25 minus y square. Now replace the value of x by its upper and lower limits. What you get is 5 integral 0 to 5 sin inverse. This x will be replaced by the upper limit. So square root of 25 minus y square over 2, and this denominator is denominator is 2. And this term is 1 over 25 minus y square will be remaining there. Minus lower limit is 0, sin inverse 0 is 0 dy. So this will give you 5 times 0 to 5 sin inverse. This term and this term will be cancelled. So sin inverse 1 over 2 into dy, and sin inverse 1 over 2 is pi by 6, which will give 5 times integral 0 to 5 pi by 6 dy. So 5, next we will write area of S is equal to 5 times pi by 6 integral 0 to 5 dy, which is 5 into pi by 6 y from 0 to 5. So it's 5 into 5 again 25 pi over 6. That's the end of this problem. And I think all the problems have been solved from this PowerPoint. That's the end of this chapter. And you can see the answers here available. That's the end of this one. We'll see chapter 9.14 for week 10 in the next video. Okay, thank you very much.